So we've seen that the equation of a parabola whose vertex is at 0, 0 and whose focus is at 0, a has this equation, 4ay equals x squared. So it seems to be expected that a shows up in this equation somewhere, because after all, it's this little constant a that determines where the focus of the parabola is. But it's a little surprising that what shows up isn't just a, it's actually 4 times a. So, I mean, it kind of makes you wonder, what geometrically does 4 times a actually represent? And so let's have a look at that. So let's sketch this parabola. So here's our coordinate system. The vertex is at the origin, and the focus is at 0a here. Remember, that means the directrix is going to be down here at y equals minus a. Okay, and the parabola is going to look something like this, I guess. It's a little hard to know exactly how wide to make the parabola. We don't, as humans, we don't have great intuition for how wide that should be. Okay, so remember, the defining property of a parabola is that if you pick any point on this parabola, the distance from that point to the focus is the same as the distance from that point down to the directrix. All right, so a is the distance from the vertex to the focus, so it's the focal distance right there, which is the same as the distance from the vertex to the directrix. That's right there. Those are both a. But again, what about 4a? It seems like maybe that should be some special distance on this diagram. Well, there's really only one other special point on this parabola besides the vertex, and I guess that would be these 2 points that are to either side of the focus. So let's look at those 2 points. For example, we could ask, what is the distance between them? Well, we don't really know immediately what the distance between these 2 points is, but the distance from one of them to the middle, well, that's from this point to the focus. So that has to be the same as from that point down to the directrix. So these 2 distances here in red, these have to be equal because that's the defining property of a parabola, that the distance from the point to the focus is the same as the distance from that point down to the directrix. But the distance from the point down to the directrix, that's just the same as the distance from the focus to the directrix, so that has to be 2a. But that means this red length on top is also 2a. Well, look, this is symmetric about the middle of it, so this blue distance on the right is the same as the red distance on the left. That's also 2a. And if you add them together, the distance between these 2 points is 4a. So that's what the distance 4a is. It's the distance between the 2 points on the parabola that are level with the focus. This distance gets called the lattice rectum. Sometimes you'll also hear about the semilattice rectum, which is just half, which is 2a. So that's what the 4a means. A by itself is the distance from the vertex to the focus, and 4a is the distance between these 2 points that sit beside the focus. To get a feel for sort of how all of this fits together, let's look at an actual parabola. So this parabola is being generated on the fly. I can move the focus around, and you can see the directrix down here moves to keep the vertex at the origin, and as we move the focus up, the parabola opens up further, and as we move it down, the parabola gets narrower. So let's just measure all of these distances. First, we need the points that are even with the focus. So that's going to be something like here and here. And let's measure the distance from that point down. So GeoGebra is telling me that's about 4.03, and the focal distance here is 2.06, and if you multiply that by 2, sure enough, you get almost this distance from these side points down to the directrix. It's not exact because I haven't sort of carefully coded GeoGebra to make things exact. We can also measure the distance from this point all the way over to that point, so that's the latus rectum, and that's 8. And sure enough, 8.06 is about 2.06.